Why starting torque is high and starting current is low in slip-ring induction motor. Let EMF induced in the rotor is E2. Let resistance of rotor winding is R2 and reactance of rotor winding is X2. Torque T is equals to flux into I2 into cos phi 2, where flux is mutual flux linking stator and rotor, I2 is rotor current, and cos phi 2 is rotor power factor. Flux is proportional to stator EMF E1. E1 is approximately equals to grid voltage, which is constant. Hence, flux is constant. I2 is equals to E2 divided by under root R2 square plus X2 square. R2 is very much less than X2. Therefore, I2 is approximately equals to E2 by X2. Hence, I2 is approximately constant. Cos phi 2 is equals to R2 divided by under root R2 square plus X2 square. Since R2 is very much less than X2, cos phi 2 is approximately equals to R2 by X2. Thus, cos phi 2 and hence torque is approximately proportional to rotor resistance, and torque increases with rotor resistance. I2 is equals to E2 divided by under root R2 square plus X2 square. By increasing rotor resistance, rotor current reduces, and thus stator current reduces. By increasing rotor resistance, starting torque is increased and starting current is reduced. However, higher rotor resistance increases rotor copper loss and thus reduces efficiency of motor. In a slip-ring induction motor, external resistance is added to the rotor circuit via slip-ring set startup to increase starting torque and to reduce starting current. As the motor speeds up, this resistance is gradually cut out in steps, finally short-circuiting the rings at full speed. What is the difference between EGOR and M145E brushes? EGOR is electrographite grade of brush. This grade is less wear resistance and thus have long life. However, it has high temperature and temperature of brush gear assembly may cross permissible limit. M145E grade of brush is made of copper graphite. It has higher conductivity due to presence of copper and hence it is heated up less. Though it wears more, it can easily be replaced by lifting spring of brush holder. Copper graphite brush comes under the category of metal graphite. Silver graphite brush is also a metal graphite brush, but it is costly. While in large turbogenerator, stator winding is star connected. In a star connected winding, V phase equals to 1 by root 3 V line. Since V phase is less in a star connected winding, less insulation is required. More space for copper is available and more current can flow without exceeding permissible limit and thus increasing the rating of turbo generator. What is the meaning of journal in sleeve bearing? The portion of shaft which rotates inside the sleeves of sleeve bearing is called journal. Sleeve bearing is also called journal bearing. In the diagram shown, sleeve bearing is mounted in a separate pedestal. This bearing is called pedestal bearing. However, in large turbogenerators, sleeve bearings are mounted in end sheets, reducing overall length of generator. Sleeve bearing comes under the broad category of hydrodynamic bearing. When journal rotates, oil is pulled between journal and sleeve. Oil film is formed between journal and sleeve. Rotor weight is ported on oil film. How does a tilting pad thrust bearing works? Large vertical motor has thrust bearing and guide bearing on top and guide bearing at bottom. Thrust bearing supports axial or thrust load and guide bearings take care of radial load. Runner is mounted on the rotor shaft. It rotates with rotor. Base is fixed on stator and is stationary. Tilting pads are pivoted on the base. Tilting pads can tilt in any direction. When shaft and runner rotate, lubricating oil is pulled between runner and tilting pads. Tilting pads tilt on the pivots, and oil film is formed between runner and tilting pads. And runner is ported on the oil film. Similar to sleeve bearing, this bearing is also a hydrodynamic bearing.